One of the primary goals of the JWST is to study the solar system, including the gas giant of our solar system, Jupiter, and its fascinating features. As the James Webb Space Telescope, JWST, soared into space from French Guiana on December 25, 2021, with the grandeur that befitted a majestic space telescope of its stature, the astronomers could not help but anticipate the spellbinding images it would capture of star-forming regions in space and galaxies that lay nestled in the bosom of the universe, with the bonus of delving into the enigmatic chemical compositions of exoplanets in and out of the Milky Way. As expected, NASA's preeminent flagship space telescope has lived up to its lofty expectations. And how? In a news release, the venerable planetary astronomer Imke de Pater, a professor emerita at the prestigious University of California, Berkeley, said that the scientists did not expect the image captured by the JWST to be that astounding. The JWST, with its cutting-edge technology, has been successful in capturing pictures of celestial bodies that could not be seen by previous telescopes. This is because the cosmic expansion has caused their light to only be viewed by instruments designed to view infrared spectrum lights, which the JWST has been expertly designed to see. The James Webb Space Telescope has not only trained its lens on objects in the far-flung reaches of the cosmos, but has also gazed more intently at entities closer to our own Milky Way. On July 27th, the telescope's powerful infrared vision was directed toward Jupiter, yielding strikingly beautiful images that capture the gas giant in both its recognizable and enigmatic forms. Imke de Pater, the principal investigator from the University of California, Berkeley, declared the findings to be absolutely unbelievable, adding that the sheer magnitude of the discovery has left all the scientists in awe. The Near-Infrared Camera, NIRCam, captured 2 images of Jupiter, with one of them being an arresting close-up taken through 3 distinct filters. Jupiter's many cloud bands, auroral emissions, and storms are visible in the image. The equatorial zone, which stretches across the planet's breadth, appears brilliantly white due to the high-altitude hazes that reflect an abundance of sunlight. Similarly, the Great Red Spot, a massive storm located in the planet's southern hemisphere, appears as a vivid, luminous oval. The smaller storms scattered throughout Jupiter exhibit hues ranging from white to reddish-white. In contrast, the cyan tones signify the presence of clouds in the depths of Jupiter's atmosphere, with light mirrored back from Jupiter's primary cloud level at a pressure almost equivalent to the atmospheric pressure at the surface of Earth. Furthermore, the image shows a seamless change between the banded structures that are evident at mid-latitude and equatorial regions, which are readily observable from our planet, and the more intricate vortices that are situated at higher latitudes. Jupiter is known to display enormous auroral ovals, similar to the Aurora Borealis and Aurora Australis visible on Earth. Nonetheless, the ones seen on Jupiter are much more massive and intense, creating an awe-inspiring spectacle. These auroral ovals originate from the interaction between Jupiter's magnetic field and the charged particles inhabiting its atmosphere. These auroral ovals radiate a reddish glow, emanating from ionized hydrogen atoms and stretch across a vast distance of 630 miles above the top of Jupiter's clouds. Not only that, but the greenish areas surrounding its poles are also interesting. These areas stem from hazes present in Jupiter's atmosphere, which happen to be situated at a height ranging from about 65 to 130 miles. You should also know that Jupiter's magnetic field is one of the strongest in our solar system, about 20,000 times more powerful than Earth's magnetic field, leading to its label as the king of magnets. It is also tilted at an angle of approximately 9 degrees to the planet's rotation axis, thereby not coinciding with Jupiter's rotational poles. This peculiarity of Jupiter's magnetic field is a unique aspect that is not common in other planets' magnetic fields. As Jupiter rotates, Its magnetic field initiates the movement of the charged particles present in its atmosphere, creating a powerful electric current that courses through the planet's magnetosphere. This current stimulates intense magnetic fields and electric currents that further excite the charged particles, comprising electrons and ions, to attain high energies, generating an electrifying effect. These energetic particles then interact with the atoms and molecules inhabiting Jupiter's upper atmosphere, exciting them and causing them to emit light, which we see as the vivid auroral ovals present on Jupiter. These auroral ovals can be observed in both visible and ultraviolet light, further adding to the captivating burstiness of this magnificent gas giant planet. There is also a wide field view that combines the images through not just one, but two infrared filters. The auroral ovals and Jovian clouds are still very much present and breathtaking, but the composite photo now reveals so many more complex details that were once hidden. The immense capacity of JWST is shown by the fact that it can picture the faint and dusty rings in the same image as the bright Jupiter itself. To put things in perspective, Jupiter shines 1 million times brighter than its rings. And that's not all. According to NASA, Jupiter has 79 moons, and two of its faint inner moons made an appearance, Amalthea and Adrastea. Amalthea measures 160 miles in diameter, whereas Adrastea is a minuscule 11 to 12 miles across. At the edge of the dusty rings, Adrastea appears to the keen eye as a mere dim dot, and Amalthea is roughly twice as far from Jupiter's limb. In this captivating image, you can also see a rich tapestry of scattered light. A keen eye will detect an array of sources, including, but not limited to, diffraction spikes that emanate from Jupiter's aurora, as well as the luminous presence of Io, Jupiter's innermost Galilean moon. A closer examination reveals that the latter spike crosses two of Jupiter's visible moons, presenting a delightful sight. For example, diffraction spikes are a byproduct of reflecting telescopes like the JWST, resulting from the interaction of light with the beams that hold up the secondary mirror. However, the most fascinating aspect of the background light can be found towards the bottom of the image. According to scientists, the faint dots that scatter around this region are distant galaxies featured in the image. It is worth noting that the colors depicted in these images do not correspond to what the human eye would perceive when gazing upon Jupiter. This is because our eyes are unable to discern infrared radiation. However, the citizen scientists Judy Schmidt and Ricardo Hueso of the University of the Basque Country in Spain, who processed these magnificent images, used a mapping method that imitates how the human eye detects visible light. The longer infrared wavelengths were mapped to the red end of the visible spectrum, while shorter wavelengths were mapped toward the blue, resulting in a visually stunning image. As I mentioned earlier, the JWST's NIRCam conducts its operations by utilizing an array of filters, each at distinct wavelengths of light, to capture details that can't be easily viewed by other telescopes. The filter that operates in a shorter wavelength, with a measure of 2.12 microns, showed the immaculate white stripes positioned at the equator and the poles, while the dimmer clouds furiously swirled among them. The longer wavelength filter at 3.23 microns displays the less visible structures that surround Jupiter and its rings. These rings appear very clear at the zone directly above Europa, one of Jupiter's moons that, along with other moons like Metis and Thebe, appears substantially brighter. These images captured by the JWST demonstrate the ability of this powerful telescope to discern the subtlest of details in structures, like those located close to bright planets. This feature could prove invaluable, as the telescope's first scientific application involves capturing waterspouts that erupt from Europa and Enceladus, thought to contain vast water bodies under their icy exteriors. The image of the icy Europa that was captured by the JWST was released in July 2022, and it has caused quite a stir in the scientific community. However, the new image taken was positioned at an angle where the observation was thought to be impossible. However, JWST's image presented a different perspective. These new images highlight two smaller, yet still visible moons that can only be seen in the infrared. The capabilities of the James Webb Space Telescope are multifaceted, and it is not just images that it excels at. Spectroscopy is another field in which the JWST is making a remarkable contribution. As of July 27, spectroscopic data has been obtained from Jupiter's Great Red Spot in near-infrared wavelengths, followed by similar observations in the mid-infrared in August. The Great Red Spot is a storm of massive proportions that could swallow Earth whole, and the clouds appear white in the images due to the higher levels of sunlight they reflect. The Great Red Spot and the equatorial region both have high-altitude hazes because of the brightness in this area, which points to its high altitude. The Great Red Spot and the equatorial region possess high-altitude haze. Additionally, the presence of various bright white streaks and spots most likely denotes very high-altitude cloud tops formed through condensed convective storms. Conversely, the dark ribbons at the equatorial region's north indicate minimal cloud coverage. The recently released deep field images, along with the current Jupiter images, truly display the full spectrum of what the JWST can capture. From the most obscure and distant viewable bodies to planets within our cosmic neighborhood that are visible to the naked eye, the JWST offers an unprecedented view of the universe's vastness. Working with Jupiter is more challenging than studying more distant celestial phenomena due to its rapid rotation. We expect more findings from the JWST. If nothing, the JWST has proven itself able to garner new pieces of information about our galaxy and cosmic neighborhood. And that's a wrap on today's video. We hope you enjoy this video and learn something new today. And as always, keep exploring.